Hello everyone, in this video we will be going to learn how to program HESC 120 volt 600 amp controller. So you need to download the HESC tool from HESC website and open the HESC tool. Now second step will be to connect the controller to your laptop or PC using a USB cable. After you will connect the controller, you need to click on the connect button which is on the top in the right side. So here you can see the controller is connected and the firmware version has been shown here. So the most important part right here is you don't have to use the setup motors FOC wizard or any wizard from here. Okay, we will do everything manually. So first of all we will go to the real-time data and you need to enable the RT from here. If you don't enable it, nothing will show up here. So enable the RT from the right tab. You can see the voltage of your battery pack, and the most important thing to note is the fault should be none. There should be no fault right here. If there is some fault, there is something wrong. So make sure there is no fault here before proceeding further. Next we will move on to general, and we will adjust the motor current and the battery current here. So I am using a current limited power supply, so I have to limit the current for the power supply so that it doesn't trip out. But for the detection of mid-drive motors or even hub motors, you can set the motor current as 120 and battery current max to 10 amps, but my power supply is limited, so I am using 6 amp here. And I will write the motor config from this button right here. Next I will head on to FOC tab. Here we will perform the detection of our motor. So first of all we need to go to advanced and click on the frequency and reduce it to 5 kilohertz and dead time compensation to 2.4 microsecond. Alright, now we will head back to general tab and we will perform our detection. So click on the RL button and motor will make some noise and we will get our detection results here. So we have detected resistance of the motor as 7.24 milliohm and inductance as 51.19 microhenry, which seems alright for the QS13890H. Now we will next measure the flux linkage of the motor. To measure the flux linkage, we need to decrease the duty cycle. So this thing depends upon the voltage you are using. Good value will be around 20%. So set it to 20 and set the current to 60 amps. Then hit the lambda sign here, which is for measuring the flux linkage. Now the motor will rotate and you can see the lambda value here has been detected as 19.233. so we will apply these values. This will ask for the you to enable the MTPA and all those stuff, so we will do it later in further tutorials. Click OK and here all the values will be updated. Click on write motor configuration and the motor has been set up for sensorless commutation. If you want to test how it is working, then you can set the current in this I tab to 30 amps and enable this arrow sign from here. Click on this arrow button. So after connecting it, as you can see in the instructions, it will enable the keyboard control, and up and down arrow keys can be used for current control and left and right arrow keys can be used for duty cycle control. We will use current control here. So when I press the up arrow key, the motor will start to rotate. So here you can see the motor is rotating without any problem, but you need to make sure, I made a mistake right here. You need to change the frequencies back to 20 kilohertz and dead time compensation to 1 microsecond while running the motor. otherwise bad things can happen. So yeah, now I will click the arrow key up and you can see the motor is working. Now it's much more silent than before because we increased the switching frequency of the controller, so it's tracking much better. Alright, so